Welcome to my channel. In this video, I'm going to cover the famous event loop inside the JavaScript. Okay, so first let's go back to the code we had in last video, which is this one. Suppose here I have a console log start and setTimeout and the console log end. For the setTimeout, I give the delay time is 0. So no matter I give 0 or not give 0, it's the same. Basically, default is 0, which means delay time is 0. And we would expect the output in the console should be start, timeout, end, because 0 means no delay time, right? But it's not. We see the result is start, end, and timeout. Let's demo again here. I think I have to open in the default browser, and I'll come here and we inspect. Go to UIC start, end, and timeout. Okay, and if we add one more, no matter this one is before or after this start, okay, you will always see start. See here, I refresh start, end, and timeout, and put the beginning is also like this way. Why it looks like this way? Okay, so we are going to do is to figure it out. Okay, let's go with this. Let's go with that one. Okay, with that one. Now we have to go back to our slides. We go with some terminology here. So how is this one? We are related something called asynchronous and a single thread. JavaScript language is a single thread. And what a single thread means? Single thread, you can think it just have one stack, okay, which is this one. This stack. Stack is some, you can think is some location in the memory. And what is stack doing? Stack is to execute our function, execute our code, like inside the previous when I talk about execution context, you see all the function is pushed into the stack to execute, right? And that is stack. We also have the thing here. Stack. This represents a single thread provided by JavaScript code execution. Function calls form a stack of frames. Okay. So here, JavaScript only has one stack. And since it only has one stack, we think it's a single thread. Okay, single thread, and it means one stack. It means it can only do one thing at a time. It cannot do multiple things at the same time. It can only do one thing at one time, which means it can only execute one function at a time. And the asynchronous behavior, which because take a look at our code, which here while we execute the end. Suppose here if I give 1 second, the waiting, okay, do the ticking, waiting is waiting where? Okay, because if I'm do the waiting calculation here, like I'm counting, okay, now it's 1 second or not 1 second, I have to do calculation, right? Waiting time, and we still execute the end part. So that means we have two things being running at a time. One is waiting for the 1 second, the other one is what? The end being printed into the console. So this how this behavior happened. This is because the asynchronous behavior, which is a setTimeout, is not part of a JavaScript language itself. Instead, they are built on top of the core JavaScript language in the browser, and also other environment like a Node. Okay, and this one, which means setTimeout, this method is not belongs to JavaScript language. Instead, it's a browser give us. Okay, in the browser, it has something called the web APIs. So what kind of APIs is the web APIs? Suppose you have DOM. In the DOM, you touch an event, which is on-click event, or other on-some event. All of them are asynchronously. And suppose you make an AJAX call, which is XML HTTP request, or using a fetch to make a call to the server side. and that is also asynchronous, and it is also provided by the browser. And we learned in last video, setTimeout is also asynchronous. It's also provided by the browser. So here, we already talked about a stack, and we already talked about web APIs. Web APIs basically are all the APIs, all the asynchronous APIs provided by the browser in this case, and they are all built on top of the core Java language. Okay, and we do have other thing. Okay, Heap. Okay, which is this part. Heap is a, as the name said, okay, it's a big location which is store all the objects. Objects are located in a heap, which is just as the name denote a large, mostly unstructured region of memory. Okay, and the browser API, which is this one, browser API here, are built on into your web browser, and are able to expose data from the browser and surrounding computer environment to use for complex things like setTimeout, make a request to a server side. They are not a part of a JavaScript language, rather they are built on top of a core JavaScript language, providing you extra superpowers to use in your JavaScript code. So far we only see setTimeout. Now let me draw this part inside the OneNote and explain how actually the code is being run. Okay, so first I will copy this piece of code and I will put inside the here OneNote. Make it larger. I am tired. I'll make this one to be 0 or 1 or 2, doesn't matter. Okay, I just keep it 0. Then we have to draw what's inside the browser. Okay, and let me draw it. Suppose here this side, okay, suppose this is our Chrome. Is my face covered this part? Wait me for a second. Cover a little bit, it should be fine. Okay, this is our Chrome. Inside Chrome, it will have V8. V8 is what? JavaScript engine, which is execute our JavaScript code, right? And in the V8, we're going to have a stack. Why should I draw? I drew this part, okay, because that part. And the stack is used, it only has one, because JavaScript is a single thread, one stack. And the stack is a push function inside to call. And now we have another one, which is a heap. Suppose we create an object, and this object can be created in the heap. But when I demo for the event loop, I want to use a heap, okay. So then here we'll have web APIs. What APIs are web APIs? Like DOM APIs. Okay, document dot get element by ID and dot onClick, those are DOM APIs. And DOM APIs like those event handlers. Those event handlers like onClick, those event handlers are asynchronous. Next one, you can think you haven't learned XML or fetch, this API. They are also asynchronous, okay. And we have already learned set timeout and set interval, okay. And they are also asynchronous, okay, part of web APIs. And the other one is not a part of web API, but they are also asynchronous, called promise and async, we will learn in the future, okay. So, and besides here, we will also have a queue. This one mostly our callback queues. And here we have something called event loop. Okay. So in the callback queue, we're gonna have callbacks registered here. event loop will always check if your stack is empty or not. Only when your stack is empty, then I'll push the callbacks into a callback queue to execute. Okay. Now let's execute this piece of code. So I will have a start. Okay, here is the console log start. When we log start in our outputs, console output, okay, I will have a start being printed, right? This one over out. And after log is done, we will pop out from a stack. Okay, pop out. Now we will do what? We will do setTimeout. setTimeout, okay, the entire setTimeout gonna be pushed into the stack. And when JavaScript v8, see, okay, this is setTimeout. It's not my API, okay? Instead, it's the web APIs. So what's gonna do is here setTimeout, I have to wait for 1 second, right? So JavaScript don't do it. What's gonna happen? The setTimeout gonna be moved to web APIs. Okay, will be moved to here, and here is your callback, and here is 1 second. So here, the waiting is gonna be waiting in the web APIs, and then the setTimeout is popped out from a stack. Okay. And while we are waiting for the setTimeout, this callback, the stack continue pushed to be, the remaining code still continue push into a stack to execute. So here I have a log end that be pushed. Suppose after 1 second the timer is done. So after timer is done, we are doing parallel. Okay, in the web API part it's waiting, and in the stack it's continue execute more code. And after this waiting is done, okay, the callback gonna be put it here, which the callback function register, like in our case is the console log timeout. This function, okay, the callback gonna be pushed into callback queue, and then stack continue doing his job. And then we will have end, okay, being printed. So here pop out. So when is this callback gonna be executed? So far this callback is not executed. Just put it in the queue. When is the callback gonna be executed? It depends on the event loop. Event loop got the name because it kind of like have a while true there, and so it's a infinite loop. It's not infinite. It's keep looping here. Okay, that's why it's called an event loop, because it have something called a while true, kind of like. So event loop is doing what? Event loop is always a check stack and the callback queue. So when the stack is empty, he will push the callbacks from callback queue to a stack to execute. So after the end is printed, the stack is empty. When the stack is empty, the event loop will push this callback into the stack you execute. The callback is what? In our callback, the callback is this part. This part is just to do what? This part is just to have a timeout being printed. Okay, and after this printed, then this stack is empty, and now we will exit from the code. Okay, so that is the how this part why timeout get moved to the end, because there's asynchronous. All the asynchronous callbacks gonna be moved to the callback queue. Okay, going to move to the callback queue, and only the stack is empty. The callback queue gonna be executed. What kind of stack is empty? You don't have more code after this timeout. Okay, after this timeout, like a console log, I don't have any more code. Then my stack is empty. Then this callback gonna be pushed to execute. So that's why timeout is printed after the end. Because I'm a human, I cannot do, like I said, here is waiting. Then here also console log. So there's a very good website. I like that guy. It's called Loopy, but it has some bug there. And this guy also have a great talk on the event loop. Okay, but very old videos, and this is the one which can actually show you the event loop in dynamic, in what's the animation way. Okay, so I will do is I will copy my code. See here, I put it here, and then I will execute and run. And here we'll have we need to also open the console so we can see the output. Okay, like this way. Now this is our output. Let's see here. Okay, see, this is a call stack, this is the web APIs, and this circle thing is an event loop, and at the bottom is a callback queue. So when we have a start, it's going to push a edit 7 doesn't work properly. Okay, sometimes they have this bug. Okay, doesn't work. Save, edit. Oh, I didn't copy entire thing here. I'll make this part to be 0. Okay, I'll do like this way. 0, okay? I just give it 1 second, but this one give it 0. Line 2. Oh, this one doesn't work very well. Okay, if not, I'll just print console log start. Okay, set timeout, and here I will give console.log timeout, and then I have a console.log end. Okay, why this today doesn't work well? So oh, this way I can demo to you guys. Doesn't work well. Doesn't work. Let me reopen. Doesn't work. Okay, it has bugs. Okay, let me see Java script event loop animation. Okay, visualize. Okay, let's see this one. Okay, see this is their videos. Let's see visualizer. Let's see if this one works. Okay. This one probably work. Okay, so here it has two. One is a MacroTask, one is a task queue. It has two queue, but I forgot the names. Okay, one is called a MacroTask, the other one is called a MicroTask. One is for like a fetch. Oh no, not a fetch. One is for like a set timeout, set interval, event handler, Ajax. The other one is for promise, async and wait. Okay, let me see if this one works. Okay, I will run. Okay, you see event loop. Right, step. Okay. Okay, start. You have start here. And anonymous, and the task queue gonna have another name called a MacroTask, and the event loop you have end here. Okay, and then running a task, and it's gonna be anonymous. This one, this is not a good timeout. This one is not a good. I like that one, but it doesn't work. Okay, I like this one, but it doesn't work. Here, let me see this part. Okay. Okay, here have another, it can show a little bit. Like this. Okay, basically let me open the inspect. Okay, do like this way. So let's rerun. Let's first take a look at the code. Console log hi. Okay, and set timeout. I have function timeout, and after 5 seconds, let me change this one to be 0. Okay, and then after the end, I will say welcome to the loop. When we see in the console, we'll see hi, welcome to loop, and click the button. So let it run. See here, we will see hi, I have printed. Set timeout moved to the web APIs, and the function timeout gonna be in the callback queue, and then push into the call stack to execute when the normal code after this welcome loop, right? So you will see hi, welcome to loop, and click the button. See here, this one is a click button, which is click button is time, right? Let's save and run one more time. Hi, and push to here, and timeout is waiting here. So the 0 here is not actually the immediately. It's like the minimum waiting time. Okay, you have to suppose after the welcome to loop, I have a for loop, and the loop for millions of times. You have to wait till everything finished before we see the click the button. So this is a event loop. Okay, and here inside the browser, actually here we have two queues. Here we have two queues. And this callback for set timeout and set interval, and the event handler. If I remember the name correctly, this one is called a macro. What's the thing? MacroTask code. MacroTask queue. Okay, this one. And there's another queue called the micro. Oh yes, MacroTask queue. And this MacroTask queue is to hold all the callbacks for the promise and the async wait. Okay, and this queue has a higher priority than the callback queue, which is MacroTask queue. Suppose both of the MacroTask queue and the MacroTask queue has callbacks, and when the stack is empty, an event loop will push which one to there to execute. He will these callbacks in the MacroTask queue, which is promise and async await one, have a higher priority compared with set timeout and event handlers. Okay, so this is the event loop happen inside the JavaScript, and how the event loop actually give the asynchronous behavior and solve the single thread problems happen inside the JavaScript. Okay, and later on, if you go to the learn Node by yourself, Node also has an event loop, but it's very similar to what we have here. Instead, we have only two queues. Okay, Node.js has more queues, and for different queues, it can register for different callbacks. Okay, so that's it for this video. I hope you like this video, and bye bye.